Hi Form 3. This video is just to show you some examples of an extension topic, which is finding the area of a sector and length of an arc. Okay, so before we get into the example, you need to check you can know what a sector and an arc are. Now, these are both parts of a circle. So it's moving on from the area and perimeter, the area and circumference of a circle. Okay, so on the left are all examples of sectors. So these are all examples of sectors. They're sections of area of a circle, but they have not just any area like these ones. They have to come from the center and involve the radius. So the area of these is the sector, and then the arc is like a fraction of the circumference. So this curved part is an arc, and this curved part is also an arc. That would be the bigger arc. Okay, so these are sectors. Later on in maths, you'll work with these kind of segments, but for today, you're just going to be working with these types of sectors. Okay, so first example, we're going to find the area of the minor sector. Now, minor sector just means smaller sector. So this light purple thing. So just like with fractions of a circle, for example, quarter, half, and 3/4, you need to work out what fraction of the circle is this sector. Now, because it's 103 degrees, you can think of it as 103 out of 360. So this is the fraction of the circle that I have, 103 360ths. You could simplify it if you wanted to, if you could simplify it, but you can just leave it like that. So you basically find this fraction of the whole circle. So I'm going to the whole circle would have an area of 4 squared times pi, and I just want this fraction. So you type all into your calculator, and you get an area of 14.4 centimeters squared, and that's for the smaller sector, and that's area. Okay. This next example is about the length. So now I want to find the length of the major arc. Major arc just means longer arc. So they only use these words major and minor if you've got 2 sectors in your picture. But I want the longer arc. So what fraction of the circle is this big arc from? Well, it's not 103 this time because this part. So I have to subtract this from 360. And I get 257. So the green arc takes up 257 3/60ths of the whole circle. So it'll be 257 out of 360. Then you multiply this by the circumference of the whole circle. So it's going to be 257 3/60ths times the diameter, which would be 8 times pi. So the longer arc has a length of 17.9 centimeters. Now this last one, we'll give me the answer right there. This last one is I want the area and perimeter of this sector. So area is quite straightforward. So even though I don't have the rest of the circle, I still know it's 155 degrees out of 360. It's going to be 155 out of 360 multiplied by what the total area of the circle would be. So r squared times pi. So the total area of the sector is 109.6 centimeter squared. Now I said perimeter. So perimeter is the whole outside. So it's actually the curved part, which was the arc, plus the 2 straight edges. So you have to do 2 things and add them together. So the curved part, again, the same fraction, is going to be 155 over 360 times pi times diameter. So the curved part has got a length of 24.3 centimeters, but that's just the arc. So for the total perimeter, I've got to add on these 2 straight edges, which are radiuses. So it's going to be 24.3, the curved part, plus 9 for the 2 radius. And the total perimeter will be 42.3 centimeters. I hope this helps. I'll still be in the lesson if you want to come back and ask questions.